Okay, so this is a key to section 15.4, part E, and in this worksheet, you are rationalizing the denominator. Each of these 6 problems, you're asked to rationalize the denominator. Now remember, when we rationalize the denominator, so when we're asked to rationalize the denominator, the word rationalize, and the word rationalize is the word rational. So basically, what you want to do is make the denominator a rational number. That's what you're trying to do. Make the denominator a rational number. So right now, if you look at these denominators, all of these denominators, square root of 5 is an irrational number. So the square root of 5 is an irrational number. The square root of 6 is also an irrational number. So these are all irrational numbers. 1 plus the square root of 5 is an irrational number, and so on. So these are all irrational numbers. 2 minus the square root of 3 is an irrational number. The square root of 6 minus 2 is an irrational number. The square root of 2 plus 5 is an irrational number. So those are all irrational numbers. So remember, a rational number is a number that can be written as a fraction. We call it a over b, where a and b are integers. Where a and b are integers. Now obviously b cannot be 0. I'm going to say a and b cannot equal 0, because remember you cannot divide by 0. But a and b are integers. Okay, so for example, the square root of 16, so you may see every term here has a square root in it. And yes, these are irrational numbers, but the square root of 16 is not an irrational number. The square root of 16 is rational, because I can rewrite the square root of 16 as a fraction where the numerator, see, the square root of 16 is 4. And I can write 4 as 4 divided by 1, and both of those are integers. But you cannot write the square root of 5 as a fraction, a over b. It's not possible. You cannot write it as an integer divided by an integer. Okay? Where you have an integer divided by an integer. Okay, you cannot do that. You cannot write that. Okay, so that's why those are irrational numbers. So the goal is, in each of these cases, is to go ahead and make all these, to rewrite this in such a way that all these denominators are rational numbers. And it's not a difficult process. It's fairly easy to deal with. These two are extremely easy. These are a little bit more work, but it is doable. Okay, so let's talk about these two. Okay, number 1. Okay, so I want to rationalize the square root of 5. I want to make the denominator, I want to rationalize the denominator. So I want to make that denominator a rational number. Okay, so I have 2 divided by the square root of 5. All right, so whenever you see that you have one term here, this is one term in the denominator. That's it. Here you have 2 terms, 2 terms, 2 terms, 2 terms in the denominators. When it's one term, you do it differently than you would these two, than you would the 4 terms. I'm sorry, the 4 problems here, which have 2 terms in them. So if it's just one term, then here's the idea. So remember, I want to make this denominator, I'm going to leave some space here. I want to make this denominator a rational number. Right now, it is irrational. Okay, now do y'all agree that if I multiply this denominator right here by itself, the square root of 5 from the square root of 5, you get the square root of 25, which is now a perfect square. 25 is a perfect square, which gives you 5. So that gives me 5, which is now a rational number. So whenever it's just one term, you just multiply by itself. So the square root of 5 from the square root of 5 is 5. But what I do to the denominator, I have to do to the numerator. So you're going to say, you'll multiply both numerator and denominator by the square root of 5. And so the answer is 2 square root of 5 divided by 5. There's your answer. You now have the denominator being a rational number. So basically what you found is this. 2 divided by the square root of 5 is the same thing as saying 2 square root of 5 divided by 5. That's what you just found. Okay? And it kind of makes sense because I want you to notice something. I just want you to notice something. If I were to cross multiply, remember I have a proportion here. I have a fraction equal to a fraction. So if I were to cross multiply, 2 times 5 is 10. And if I look at this right here, I have, and again I want to see that's equal to the square root of 5 times 2 square root of 5. Well, remember the square root of 5 times square root of 5 is 5. And so 2 times, this becomes 2 times 5, which is also 10. All right, so what I have is correct. So you can always, many times, just check your work, especially with these. These are easy to check. All right, now number 2. Same idea with number 2. You have negative 3 divided by the square root of 6. Negative 3 divided by the square root of 6. So notice I have one term in the denominator. One term. It's irrational right now. To make it rational, to get this to be a rational number, I'm going to multiply the denominator by itself. I'm going to say times the square root of 6. Because the square root of 6 times the square root of 6 is the square root of 36, which is 6. So now it's a rational number. But what I do to the denominator, I have to do to the numerator. So I get negative 3 square root of 6 divided by 6. But remember the directions also say simplify. So you always need to simplify if you can. So I can reduce the negative 3 and the 6 here. So the answer then would be, so again I have this. So I'm going to reduce 3 goes into 3 one time, 3 goes into 6 two times. So I get negative square root of 6 divided by 2. So negative square root of 6 divided by 2. Okay? All right, so number 1, the answer is 2 square root of 5 divided by 5. And number 2, the answer is negative square root of 6 divided by 2. Now, don't make a mistake and reduce the 2 into 6, because this is not 6. That's not 6. That's the square root of 6. And the square root of 6, if you use your calculator, is 2 point something. So it's not 6 here. So don't say that's square root of 3, because it's not the square root of 3. All right, number 3. Now, let's talk about number 3. So number 3, we have this. And I think I can do the work here. So number 3, you have 2 divided by 1 plus the square root of 5. I just went ahead and rewrote this. So notice that these are binomials right here. And so what you're going to do is you're going to multiply. You're going to multiply the numerator and the denominator to make this rational. You're going to multiply the numerator and the denominator by what's called the conjugate of the denominator. The conjugate of the denominator. So the conjugate, C-O-N-J-U-G-A-T-E, conjugate of 1 plus the square root of 5 is 1 minus the square root of 5. So basically all you're doing is just changing the middle sign here. The conjugate of 1 plus the square root of 5 is 1 minus the square root of 5. Okay? All right. So I'm going to say this. 1 minus square root of 5, 1 minus square root of 5. And so notice that when I multiply the denominators, those are two binomials. So I'm going to use the FOIL method. When I multiply the numerator, that's one term times two terms. So I'm going to distribute. So basically I have this. I have 2 times 1 minus the square root of 5 divided by 1 plus the square root of 5 times 1 minus the square root of 5. That's what I have. And so I'm going to distribute the numerator. I'm going to distribute the 2 rather. So I get 2 minus 2 square root of 5. Now the denominator, when I FOIL it, whenever you're multiplying conjugates, I want you to notice something. 1 plus the square root of 5 times 1 minus the square root of 5. When you multiply conjugates, the outer and the inner, see the outer is a negative square root of 5, the inner is a positive square root of 5, they add up to be 0. That's always going to be the case. And so basically, when you FOIL this, you're just looking at the first, 1 times 1 is 1, the outer and the inner add up to be 0, and you get a positive square root of 5 times a negative square root of 5. So square root of 5 times a negative square root of 5, that's a negative square root of 25, which is just negative 5. So you get 1 minus 5. So square root of 5 times a negative square root of 5 is negative square root of 25, which is negative 5. And so 1 minus 5 is a negative 4. So that's the denominator. So 2 minus 2 square root of 5 divided by negative 4. Now, the direction says to simplify. Now, what they mean here by simplifying is this. If you notice all this 2, 2, and 4. Forget about this being negative 4. Just look at the 4 for right now. All these numbers I have circled are divisible by 2. So 2 into 2 is 1, minus 2 into 2 is 1. So that's 1, and that's going to be 2. So you get 1 minus, and then 1 square root of 5 is just square root of 5 divided by negative 2. So that will be your answer there. So this will be 1 minus the square root of 5 divided by negative 2. So 1 minus the square root of 5 divided by negative 2. Okay? All right, number 4. So when you do number 4, you have negative 4 divided by 2 minus the square root of 3. So again, you have a binomial. It's not as simple as this one. This one was much simpler. Here, you have a binomial, so you can multiply both numerator and denominator by the conjugate. You're using the conjugate. And the conjugate of 2 minus the square root of 3 is 2 plus the square root of 3. 2 plus the square root of 3. And so you can multiply both numerator and denominator by 2 plus the square root of 3. All right, and then what you do next is you're going to write this as one fraction. So you're going to say negative 4 times 2 plus the square root of 3. Put that in parentheses because every term here has to be multiplied by negative 4. And then over here, you're multiplying two binomials. So you're saying 2 minus the square root of 3 times 2 plus the square root of 3. And so if you get rid of the parentheses in the numerator, that's just a matter of distributing. So you get negative 8 minus 4 square root of 3. And the denominator, if you look at it, if you go ahead and rewrite it, and then FOIL, remember those are conjugates, so the outer and the inner, so notice the outer is 2 square root of 3, the inner is a negative 2 square root of 3, those have to be 0. And so you're just left with first, 2 times 2 is 4, and then a negative square root of 3 times a positive square root of 3 is a negative square root of 9, which is a negative 3. So you have 4 minus 3, which is 1. And so in terms of simplifying, they just want you to notice that any expression divided by 1 is that expression. So you need to write the answer as negative 8 minus 4 square root of 3. Okay? All right, number 5. So number 5, you have 6 divided by the square root of 6 minus 2. 6 divided by the square root of 6 minus 2. Okay, so in this particular case, same thing. You have two binomials, and it just so happens that the square root of 6 is listed first, whereas over here, the square root was listed as the second term. But just leave it like this. There's no big deal. You can leave it as the square root of 6 minus 2. In fact, I would probably leave it as that, because if you wrote it as negative 2 plus the square root of 6, and you multiply by the conjugate of what you see, it would be a little bit more difficult. All right, so just leave it like this. And so you would say, all right, the conjugate of the square root of 6 minus 2 is the square root of 6 plus 2. Okay, no big deal. Just leave it like that. And so you're now going to write this as one fraction. So you're going to say 6 times the square root of 6 plus 2 divided by the square root of 6 minus 2 times the square root of 6 plus 2, just like you did before. And then you get rid of the parentheses. To get rid of the parentheses in the numerator, you're going to use the distributive property. So I get 6 square root of 6 plus, and then 6 times 2 is 12. Divided by. All right, now remember these are conjugates, so the outer and the inner. If you look at the outer is 2 squared root of 6. The inner is negative 2 squared root of 6. They add up to be 0. But the square root of 6 times the square root of 6 is 6. Square root of 36 is 6. So remember the square root of 6, the square root of 6 is the square root of 36, which is 6. So that's how I get this 6. And then the last, a negative 2 times a positive 2 is a negative 4. And so I get, and I'm going to go ahead now and put the 12 first. So I'm going to put the radical at the end. So I get 12 plus 6 squared root of 6 divided by 2. And you didn't have to. You can left it as 6 squared root of 6. No big deal. Now, simplify. I want you to know it's just like when we did the other problem. If I can find it. Let's see. Yeah, this one right here. When we did this one, we circled these 3 numbers, and we saw that those 3 numbers right here were all divisible by 2. So we simplified that. Same thing here. I want you to notice that these 3 numbers I'm circling, they're all divisible by 2. So 12 into 2 is 6, plus 6 divided by 2 is 3. So I get 3 squared root of 6. And then 2 divided by 2 is 1. But remember, this right here looks now like this. So you want to rewrite it. You want to rewrite it as just 6 plus 3 squared root of 6. Okay? All right, so that's number 5. And then finally, number 6. When you do number 6, so number 6, you have negative 8 divided by square root of 2 plus 5. Negative 8 divided by square root of 2 plus 5. So notice that you have 2 terms here, so you got to use the conjugate. To make this a rational number, you use a conjugate. All right, so notice all these problems we've done. Number 4, to rationalize this denominator, I multiply by the conjugate, and notice I ended up with a rational number, 1. 1's a rational number. When I multiply these 2, to make this a rational number, I had to multiply by the conjugate. Notice when I multiply the conjugate, I ended up with 2, and 2 is a rational number. So in these problems, you want to rationalize the denominator. So to rationalize the denominator, you're going to multiply both numerator and denominator by the conjugate of what you see. So the conjugate of this would be the square root of 2 minus 5. Square root of 2 minus 5. So what you do to the denominator, you do to the numerator. And now this becomes negative 8 times this binomial, square root of 2 minus 5, divided by, and then the square root of 2 plus 5 times the square root of 2 minus 5. And then we distribute the numerator. So I get negative 8 square root of 2, and negative 8 times a negative 5 is a positive 40, divided by, and then notice that these are conjugates, so the outer, which is negative 5 square root of 2, and the inner, which is positive 5 square root of 2, add up to be 0. And so you get the square root of 2 times the square root of 2, which is square root of 4, which is 2. So I get 2. And then a positive 5 times a negative 5 is a negative 10. I'm sorry, negative 25, excuse me. Negative 25. And so I get negative 8 square root of 2 plus 40 divided by negative 23. Okay? So negative 8 square root of 2 plus 40 divided by negative 23. And there's nothing, see these numbers right here that I would circle before? The only common factor they have is 1. So there's your answer right here. Now if you wanted to, you could put the 40 first. You could have said 40 minus 8 square root of 2 divided by negative 23. Okay, no big deal. And there are other ways of writing this answer, but this is fine. Okay? All right, so that should take care of this worksheet. So, oh, by the way, I did forget to mention, so remember you want to rationalize the denominator. So to rationalize the denominator, you multiply the conjugate, and notice when I multiply this out, did I end up with a rational number? And notice I ended up with negative 23, and so yes, I did. Negative 23 is a rational number. So I rationalize the denominator. I just need to simplify if I could. Okay, so that takes care of this worksheet.